Welcome back, Generals, to another Let's Fix Generals at 0 hour to make the best game ever. Good. Before we jump back at code, let's see if there are any... we wanted to review this guy here. Yeah. To review this guy. Yeah. What was the latest status here? What was the response to this? Okay, so oh boy. What is the current state of this change? Okay, so back to this guy here. The X wrapper takes the X text mass text man. What is this? Okay. Takes DX wrapper. Is there any mention of this format in here? There is. Display formats. DX8 wrapper. DX8. I don't know what other file would be better to add this function. So I would probably just put it somewhere here. I don't know yet if it should be in a DX8 wrapper class. It has already a lot of static functions, but it also has an init and a shutdown thingy. So that's weird. Yeah. These are all protected. Utilities. You can put it here. Mm-hmm. Static static int unsigned int bytes per pixel. Formats. Oof. Inline. Okay. Okay. Okay, and this one doesn't exist. So 32-bit formats. Let me give ChatGPT all the different formats. Here are all available formats to use. Good. Can now write a complete, explicit DX8 error accurate helper. Show me. What is this formatting here? Okay. It matches hardware reality. Okay, let me copy this bullshit here. Let me copy it from here. So. It still complains about some. Where did this come from? What? Huh? It is here. Huh? D3, D9 types. Oh, I'm in the wrong file. I'm in the wrong file. How did I get there? D3, D8 types. D3, D formats. Sorry, I sent the wrong one. Here's the correct one. No problem. This is a real DirectX set, and it's much cleaner. Show me. No. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay, that looks promising. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Cool. Bytes per pixel. Mm-hmm. 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 Let's clean this up here a bit. 8-bit formats. 16-bit formats. My gosh. Why did it do that? Hmm. Can we change here this shit? Block compressed. Two 16-bit components. Huh. Why does it say 64-bit format here? Let me ask. Although it sounds like 64-bit, it is 2 16-bit. Then why did it put it under? then put it in here. Let's do that. Yeah. Okay, 1, 2, 3, 4, and then we have a bunch of zeros. Okay. Non-invalids. Okay, that looks good to me. Then we remove this here. Okay, then we have a full coverage of this shit. That's nice. Bytes per pixel. Okay. Then takes 8 wrapper bytes per pixel. And then we can use it in smudge here. So we say now unsigned int bytes per pixel, and then bytes per pixel equals dx8 wrapper format. Bytes per pixel. And then we say if bytes per pixel is 0, then go to error. Okay, cool. I think we can remove this comment here. Okay, cool. Then that should do. Smudge. Then we call this make copy rect function save and add dx8 wrapper bytes per pixel function. Okay. So is there anything else we can identify? The good thing is there is not so much code in this file. Right. So there is some error in here and we can't identify what that is. Let me just copy paste this whole shit to ChatGPT. I know I already did that in the past, but let's do it again. Given the following code, can you identify any other unsafe operations? Yeah, I will paste the whole copyright header, everything in there. Yeah, so it has some context. Let's go. Yes, beyond the pitch format issues you already fixed, there are several other operations. Copyright. Missing bounds validation. Oof. There's no validation that is rectangle lies inside the render target. Buffer overrun when buff size is smaller than total size. You clamp total size, but you still copy height rows unconditionally. You clamp. why this is unsafe. If buff size smaller than height times row size, total size is reduced. But the loop still copies all rows. Buffer overflow. Limit rows. Okay. Copy rect. So max rows. Max rows. How about we call it row count? Row count, total size divided by row size. Okay. Buffer overrun when buff size is smaller total size. You clamp total size. Missing bounds validation. There's no validation that this rectangle lies inside the render target. Width, height. Left. Yeah. Okay, how is this used? Copy rect. Zero block size. Missing bounds validation on source rectangle. Yeah. I mean, it's not necessary because we don't really use it that way, but yeah, we can use debug assert crash. Is larger equals 0. Valid size. Copy rect. Valid. Top, bottom. So right needs to be smaller than desk width uint long. long. Height. Okay. I think assert is good enough. No need to clamp it, really. Buffer overrun. Yeah. Draw primitives UP with stacked memory. Why this is unsafe? Subtle. DX8 does not guarantee that draw primitive UP copies vertex data immediately. Oof. Some drivers from the pointer read after return. Oof. What? This works most of the time, but it's technically undefined. Really? Where is it? This here? Huh. Oh, that's wild. DX8 does not guarantee copies vertex data immediately. Huh. Test hardware support. Okay, but this is this is only something that is card supports effect. Why is this done on every call? Wait. What is this? So on every render update, it tests hardware support. Is that right? Is this cached, the results? Ah, yeah, it is cached. Okay, so it only does it once. Okay. I see. I don't expect that this is a problem. Unknown. False. Okay. Let's put the breakpoint here. Okay, so the first time we draw, it then goes in here. Okay. Mem set. Copy rect. Oh, so this copy rect function is only used for this test here. That's it. Huh. Okay. It's used for nothing else. You know what? How about... How about we remove this call and see what happens? Yeah. We don't test for support. We just go straight ahead and use it. Let's remove this hack again. Yeah. That doesn't fix it. Okay, so it's not related to this function, this problem. It's not related to that. Okay, what else does he have in store? Reliance on exact color comparison. This assumes no color space conversion, no dithering, no precision loss. This breaks. Different RT formats. Why it worked. Not portable. Safe approach. Mask only RGB channels. Integer overflow assumption in index. Buffer generation. Later. Fin vertices per smudge. 4 triangles per smudge. 12 indices. If anyone changes smudge draw size, smudge topology, vertex count without updating all 3 places, silent corruption. Not unsafe today, but brittle. I don't care. GPU, CPU synchronization hazards. Copy rects, log rects. This forces a pipeline stall. Where's that? Yeah, okay, but it's only done once, right? Not unsafe memory-wise, but extremely expensive. I don't care. Partly mitigated, but not guaranteed. Using render target contents without explicit state restore. Oh, later rendering assumes all previous states restored. Architectural hazards, where using render target contents without explicit state restore. Set shader, set texture, apply render state changes. hard-coded reliance on one power of 2 behavior. Set dx8 texture stage state. Clamp is honored. Correctness fragile. Where is this? Silently bail without logging. Yeah, I don't care. Lifetime assumptions with dynamic vertex buffers. If the wrapper does not fence GPU usage or internally ref count the buffer, then overwriting dynamic VB memory too early can corrupt in-flight draws. Lifetime assumptions. What's the problem here? If the wrapper does not fence GPU usage or internally ref count the buffer, then overwriting dynamic VB memory too early can corrupt in-flight draws. Dynamic VB memory too early. If the wrapper does not fence GPU usage. Okay, so out of all these, only this one looks like an interesting hint. Lifetime assumptions. Fence GPU usage. So dynamic VB access class. Yeah. Okay, can you elaborate about the vertex problem? Yes, very real and subtle hazard. Lock, unlock. Is that true? Let's see. buffer. Once draw triangles returns, the GPU is done with the vertex data. That assumption is false. What actually happens? CPU versus GPU timeline, CPU thread. Log VB, write vertices, unlock VB, draw primitive, GPU thread. Still processing previous frame. Eventually consumes VB data. Important points. Draw primitive, queues work. The GPU may read VB data milliseconds later. The CPU immediately continues execution. If the VB is reused before the GPU finishes, data corruption. Oof. Well, it's being deleted. Right? So it will release a vertex buffer here. Is that a problem? When this causes bugs, flickering geometry, randomly stretched triangles, vertices snapping, works on NVIDIA, broken on ATI, classic. Yeah. Only breaks at high frame rates. Disappears when you add logging debugging. Okay. Why it often worked anyway. Small buffers. If your VB is small and reused infrequently, the GPU catches up before reuse. The GPU catches up. Implicit driver stall. Some drivers stall on lock. This hides the bug but kills performance. Wrapper accidentally synchronizes. It's a temporary object. Its destructor may run immediately after the call. It does. Destructor likely unlocks or releases a buffer. Yes, it does. GPU may not have consumed the data yet. And how do we fix this? Ring buffer. One large dynamic VB. No override if GPU is not done. Okay, it's a country chunk. This is overwritten data. Does it unlock in destructor? Does it store an offset? Does it track frame and next? Let's take a look at it. Vertex buffer. So, what does it do? Vertex buffer class. So we allocate the info class here. Vertex buffer. Hold on, this is not here. Dynamic VB access class. There we go. So it allocates a dynamic buffer. What is this? Oh boy. DX8 lock. Write lock class. This is write lock class. Okay, so I have I want to make a test. So how about we test what happens if we if we sleep here a bit, sleep for, I don't know, 100 milliseconds, yeah? So this will be very slow then. Let's do 10 milliseconds. Yeah. Bit of sleeping, okay? Doesn't fix anything. Just makes the game slow. Yeah. Usage dynamic. VB access. Buffer type dynamic. DX8. Write only. Write only. T type T. Type dynamic. Allocate dynamic buffer. Okay. So this is that. Vertex buffer class. Usage dynamic. Usage dynamic. Software processing. Vertex buffer class. Create vertex buffer. Dynamic. You must see. VB creation flags. So we do see this, but we don't see this. Minimal safe fix. Triple buffer. What? One dynamic VB per frame. If you can't redesign everything, keep 3 VBs. Rotate every frame. Triple buffer. One dynamic. Okay. It does set right only here. Okay. Okay, so it is right only and dynamic. Yeah. Let's step in there, yeah. Let me go to smudge. Oh boy. There is 3D smudge here. Put a breakpoint here. Oh, we already edited it. Let's let's retry. Oof. Okay, so go in here. Allocate. Oh, I missed it. Oh, it already. Huh? Is this static? Oh, what is this? Static. Oh. Oh. I'm confused. Why does it use a static vertex buffer? What is this? Delete the VB and adjust the size. Oof. Any room at the end of this buffer? So multiple, so vertex buffer is shared. That's my takeaway here. Okay. Shuffle buffer. Rotate every frame. Frame. Okay, so that's interesting. So we have a vertex buffer, and it's the static one. So if we use this guy here, the dynamic VB access class, which is done in many places, then it's always using the same buffer. Okay. Let me read the description for it. Dynamic vertex buffer access is a wrapper to a single cycled dynamic vertex buffer. Dynamic VB access gains an access to the dynamic vertex buffer, and only of these are allowed at any one time. The dynamic VFV buffers are always of the same type. Dynamic vertex buffers accessors should only be used locally. Okay, let me send that to ChatGPT. Here's a vertex buffer class. So we paste this shit, and then we also paste all the functions. Let's see what it says about that. VB access, vertex, dynamic. Did we paste the correct thing? Yeah. So we take this here and yeah, all this. Okay, let's send this. Great, thanks for posting. This implementation is fundamentally correct for DX8 dynamic vertex buffers. The problem I want about is explicitly handed here via a proper ring buffer, no override discard strategy. What follows is a precise breakdown of why this is safe and what assumption it relies on, and the few remaining edge cases. The original concern revisited. GPU may still be reading from the vertex buffer where the CPU reuses or overwrites it. That concern does apply in general, but your implementation explicitly avoids it. Single large dynamic VB. Exact pattern recommended by Microsoft. Single large dynamic VB, ring buffer allocation. No overwrites. No override. Discard when wrapping. Discard. One writer at a time. Textbook DX8. Ring buffer allocation. Each gets a unique slice of the buffer. Never overwrites previous slices in the same frame. So the next allocation moves forward. I see. Frame changed. Okay. And this function is called every frame, yeah? Let me see. Flush. BPX is flush. Flush. Two particles. There are multiple callers and render. Begin render also calls it. How often is this thing called? Frame changed. Okay, there's a smudge. There are possible some smudges to render, so make sure background particles have finished drawing. Flush. Draw sorted translucent polys like particles. Flush. Possibly some smudges to render. Make sure background particles have flushed. Cross. Flush. Okay, so it first flushes everything. So when does this come? Do particles. So it comes at the very end. It's the last thing that we render in the frame. It looks like the very last thing. And it flushes before we render. There's a lot of flushes. So, but frame change false. False. Let's see when it returns true. True. On begin render. Okay, that makes sense. Begin render. Fair enough. Actually, it's called right after the flush. What is this? End render, begin render, true. Okay, it's interesting that this is actually the first time after the new frame that it's calling this again. Can we make this a user option to opt in or out of fixed aspect ratio videos. Frame changed. False. Some smudges to render. So I wonder what happens if we remove this thing here. Let's see. Just test. Okay, let's test this. I still don't know what the problem here would be. Oh, we see something now. That's interesting. Okay, that's very interesting. I mean, it looks bad, but at least we see something. Interesting. Looks very bad. Yeah. Interesting. Possibly some smudges. Okay, then let me get back on the question regarding here. Can you elaborate why drop primitive cannot be used with stacked memory? Small data, immediate mode drivers, most vendors copied eagerly, still unsafe. Use a static buffer or dynamic VB, which you already do elsewhere. But they all use it here from stack memory. All these guys. Draw primitive UP. This method is intended for use in applications that are unable to store their vertex data in vertex buffers. This method supports only a single vertex stream. The effect of this call is to use provided vertex data pointer and stride for vertex stream 0. It is invalid to have the declaration of the current vertex shader refer to vertex streams other than stream 0. Vertex data does not need to persist after the call. Okay, so ChatGPT is just making up bullshit. Completes its access to that data prior to returning from the call. When converting a legacy application, you must add a call to set FVF to use a fixed function pipeline or set vertex declaration to use the vertex shader before you make any draw calls. Set vertex shader, vertex declaration. It does something here. Yeah. So this row count thingy, let me see that again. Row count. Let me put a breakpoint here. Let me revert this other stuff that caused now bugging. Okay, already changed. Okay, I think this was the only thing that needed touching here, right? Or was there more? Oh. Is this correct? No. Okay. Okay, let's take a look. Oh boy. GitHub is slow. Okay. Okay. Message. Message str. Okay. Okay, cool. Yeah, that's good. Same here. Okay. Okay, did we miss anything? Cool. So terrain logic. Mm-hmm. Okay, I can't see any fault here. This one was solved, this one was solved, and this one was solved. Okay, then taking out the trash. Trash. So, this change. Let's get our microwave tank in the view. Okay, so row count is 8, which should be identical to height, right? Now, H, height, where's height? Here, 8, okay. So total size divided by 32, height, okay. Row count, okay, cool. Okay, row count 256, 8, 256. Good. It still doesn't show, but yeah, okay, then make function safer. Okay, I don't know what else to fix here. Integer overflow assumptions. I don't care. Are there any other errors? Are there any other suspicious things in Smudge Manager? Yes. Hardbox. Copyright. Not pitch this time. Okay, but I already did that. No clipping, already did that. block format, suspicion if the render target format is, then bytes per pixel is meaningless. Yeah, that doesn't happen. Why this matters? Linear row copies, yeah. Invalid, yeah, I don't care. Reading back. This hardware suspicion. This forces CPU, GPU, CPU readback. Pipeline flash hard store on some drivers. First readback may see incomplete data. The dummy draw call hack is a red flag. Suspicious because it means a real driver bug exists. The pipeline sometimes doesn't flush. Why it's actually okay. This confirms the engine already observed undefined behavior and fixed it empirically. This isn't unsafe, it's defensive, but it tells you the render order and state lifetime is fragile. Not unsafe, but uses system memory, forces driver to mem copy, often forces synchronization. Fine for two triangles, but combined with readback, this magnifies store. I don't care about store, it's just called once. Vertex color packing assumes ARGB layout. This assumes, yeah, alpha. On DX8, this is almost always true, but it is an assumption. Lack of overflow check in math heavy sections. If W is around now, UVs explode. Clamp marks the symptom. Not a memory bug, but a correctness one. No rec clipping. Block. Clearly battle tested. Yeah, clearly. So many clear bugs in there. Driver specific hacks, yeah. Readback pass. What's this readback pass shit? Reading back from a render target mid-frame. Where? Draw primitive. This forces GPU to CPU readback, pipeline flush, hard store. On some drivers, first readback may see incomplete data. And how do we avoid that? Okay, how do we avoid GPU sync hazard? How do we avoid the problem in this? How do we mitigate? How do we mitigate the GPU sync problem? What the driver must do before log rect returns, GPU must finish the pending draws. The pipeline must flush. The CPU must wait. Hard sync point often forces full command buffer flush. Sometimes returns stale data if the driver reorders. That's why this code is slow. I don't care. Sometimes fails without the later dummy draw hack. Is extremely timing sensitive. Constraints. Limited, blah, blah, blah. I cannot fix. Run once only. Yes. Force GPU completion explicitly. Isolate and warm-up phase. Hide the stall. During rendering. Runs lazily but still. During rendering on a rear frame with live GPU state. Fix. Run it at startup. Yeah. Yeah, that's a good point, yeah. Would be better to do it at initialization. Yeah. Yes, actually a good point. Why is it done on first? Why is it done on first? Why is it done on first use? Render. Can we do if yes, if not yes, then return, and then we put this function now in the constructor here. Oh, init, after init. Yeah. Let's try that. We have not done the test yet. So texture, yeah. False. Oof. Can't do the test unless we are rendering the texture. Oof. Okay. Why? May I remove this? Yeah. Brute force. Compare the two buffers to see if they match. Don't match. Okay, so it needs to do it lazily. Okay, well, then we can't do that. Then we reset this shit again. Yeah, I don't have any other ideas. Yeah. Then I would just push it. Then I will. So it's this guy here. Can we test? Can we test again? I pushed a few more. Pushed. Yeah, one more tentative fix. Okay, so this one, I think we can merge now. Clang tidy apply. So hold on. Refactor. Apply clang tidy fixes. Labels refactor. This one is resolved. Okay. Oh, it doesn't compile. Well, that sucks. What is the error? Initialization, skip. Ugh. Ugh. Smudge. 220. 220. Oh. Oh. Right. And why? How about we just call it row? Row. let's take that as well. Good. Let's get back to our camera branch. Let's do a rebase on main. Let's make a copy first. I'm really cautious about this because the branch is now already so big. I don't want to lose any progress. Okay, then we do rebase. Oh boy. There we go. Then I will go to main branch again and I will do another pull. Okay, and then can delete this one again. End scene begins scene. Oof. Still stores. Reduce this need for later hacks. Read back by 1 frame. Assume yes. Better approach. Use cap bits. Can auto gen mid map. Use cap bits, not read back. Does rendering to texture preserve color correctly? Use cap bits. I could try that. Okay, use cap bits. Yeah. I don't know what it is, but sounds interesting. Let's see if there's already... Doesn't exist. Gen mid map does not exist. Mid map slot buys. Mid map can do a mid map textures. What would happen if we would we would run this smudge code on hardware that does not support it. If you run the current smudge running on hardware that does not properly support render texture or the exact behavior being tested, you will run into a few potential failure modes. Let's break them down. Visual artifacts. The smudge texture might be filled with black garbage. Blending operations may produce missing smudges. Completely opaque or transparent smudges. Smudges in wrong positions. Basically, the smudge effect will look broken. Well, it does. It does. Yeah, it does already on my machine. GPU driver errors or undefined behavior. Potential performance, safety mechanisms. Detect unsupported hardware. It draws a tiny quad with a known color, reads it back, compares the results. If the GPU fails the test, no, render will immediately return. Smudges are simply skipped and the engine continues without them. So the code is technically safe. It won't crash or corrupt memory, but the smudge effect will be disabled. What could still go wrong? Even with a safety check on buggy drivers, the test itself may stall or produce incorrect results. Very old or exotic GPUs might fail to render the test quad correctly. Return a locked surface that isn't mapped properly. Return garbage data. The worst case outcome, without proper detection, frame freezes, driver reset, incorrect smudges. Smudges render correctly. We detect it. Go. Generate whatever. Goals. Avoid readbacks from GPU. Detect smudge support. Get device caps. Well, this doesn't exist here. DX8 caps, it doesn't have this. Doesn't even have it does have caps too. Can manage dynamic textures. Let me see, D3, D8, D9 caps. Do we have that? No. We do. Caps too. This one does have it. DX8 does not have. D3, D9 caps. 8 caps. It has the following. Perfect. Thanks for the clarification. You're right. DirectX doesn't have. We need to base as much hardware support on what DX8 actually exposes. Relevant caps for render to texture support are mostly about dynamic textures and usage checks, because DX8 only added RTT for certain formats. if you want to be extra cautious, verify dynamic texture support. Yeah. Dynamic textures are required if you want to update the smart texture each frame efficiently. Okay, combine the function with test. Is this one already in our dx8 caps function class? No. Dynamic texture. Okay, never used. Okay, I guess we can try this. Yeah, maybe that helps with some computers. Yeah. Okay, what's the time? 2 hours exactly. Do we still use STL port anyway? Huh? 1958. In VC6 builds. Good, I will take a break here. And then the next session, maybe we can just do what Chad has suggested here. We throw out the copy rect function and we just put the simpler version here and hope that this detection works well enough. Yeah. Let me ask, so detect smart support is practically identical to what was this test hardware support to the previous hardware support function. Not quite. They achieve the same end goal, but the approach is fundamentally different. Renders a test rectangle to a render target, uses copy rect to read back GPU rendered pixels. The system memory compares buffers. Problems forces GPU to CPU sync, which is very slow. Pipeline stalls, relies on specific pixel format behavior of the GPU, which may vary. Does not render anything, uses capabilities and format queries, checks, ensures dynamic textures are supported, calls, render target, ensures the device can render to a texture, Benefits, fully GPU safe, no readback, deterministic, fast, works consistently. Okay. Okay. I trust chat on this. I have no idea. I mean, the code looks fine. It tests for the caps. It checks something here. Yeah, so looks like code, right? Looks like code, thumbs up. Yeah. Okay, good. Then we'll take a break here. I wish you a great day or night. Until next time. Goodbye.